you know, you can go to your box or to your outlet or whatever, and you can use the probe to see which ones are live. All right, folks, welcome back to another adventure in the garage. For those of you that are new to the channel, my name is Luke, and today we're going to be going over all of the test settings on the Jonard Tools AMM-600. For those of you that are new to multimeters, we'll be going through every setting and showing you some different examples. And if you're simply just browsing around looking to upgrade your current meter, this will be a great video to showcase all of the different features of this particular model. If you found this video helpful, please go ahead and give me a thumbs up and subscribe to the channel. We got plenty more. If you didn't find it helpful, go ahead and give me a thumbs down. If you have any questions, comments, or concerns, please let me know down in the comment section. I try to get back to everyone. With that being said, let's go ahead and just jump right into it. The biggest difference with this meter versus other meters is going to be its auto detection function, which is a really unique, cool feature that I've been seeing on more meters out there, not just on this Jonard Tools one. I believe that Tesman, and I want to say K-Weeds also has this functionality available on their meters. I know specifically there is a Tesman that I had on the show. I'll do my best to give you a link to it up here. Also had this auto function. It was the first time I was exposed to it. I didn't really get what they were trying to get at with this function. And so I wanted to give you the example that I had that gave me that click and that aha moment of why an auto detection function could be super useful. And what it's trying to indicate right here is that if you are going to test something that's volts DC, volts AC for resistance or continuity, whichever of these four tests, it will auto detect and select for you depending on what you select your probes to. Now, something that I just tried it on is if you take something like, let's take something like this tone generator. Okay, I would have no idea what this tone generator is going to output unless I had previous experience with it. And let's say I wanted to take a measurement of it so I could better understand the limitations of the application of the tone generator. Something that I could do is simply hook up my auto detecting for my meter, and it's automatically going to bring up, okay, you're dealing with an AC voltage signal at 2.6 volts. So it already pre-selected that it's AC and the voltage range, as opposed to if you're working with a manually selecting meter, you'd have to determine, okay, is it AC or DC? And then within those two different types, what is the voltage value that I'm trying to work with? So it can save you a lot of time and a lot of hassle. And then I could take it another step and be like, okay, I know it's an AC signal at 2.6 volts. I could cycle through the function buttons, get to hertz, and now I can be like, okay, it's 1K hertz. That's the signal that I'm dealing with. And that gives me, without having to get out of scope, it gives me a lot of information about what this tone generator is outputting right away. So it can be really handy if you're trying to navigate unknown waters, and maybe you're trying to reverse engineer a simple electronics project. I think this does a pretty good job at sniffing it out. I'm just gonna go ahead and leave it in the auto function. We'll go over some more examples. Once you have it in auto function, which is what it automatically turns on to, once your probes are removed from whatever test you're trying to do, it'll revert back to auto, and then you could change out whatever source you're trying to measure. Let's say we just measured an AC source. Okay, now we want to check a battery. We're still in auto, and we can just go ahead and it goes straight, okay, DC, 2.5 volts DC. But something tells me that that's not right because that is a 9-volt battery. So we might have to look into that. Let's actually see. Wow, that battery is crazy dead. So that is actually totally right. That's awesome. I was like, man, there's no way this thing's at 2.5 volts. I left this in that tone generator, and I left the tone generator on for a couple weeks. So that would make sense why this battery is so shot. But a really cool function. And then let's say we wanted to do something with continuity. We're still in auto. it'll automatically go to that continuity function. It's got the green light at the top as an indicator, super fun. And then if I wanted to measure a resistor, we could go in there and boom, it pulls it up, 146 ohms. They are an affiliate of the channel. I got a link to Jonard tools down in the link tree, but you don't have to just go with them. I just think that's a super cool function. Let's keep walking through the rest of the functionality of the meter and keep giving you more test examples so you can see what this little guy can do. We essentially went over the auto test functions, volts DC, volts AC, resistance and continuity. Let's do like another AC example. Let's actually do a manual selection of the function. So we'll go to a volts DC. Can hit this function button here. We can see we're in the volts DC measurement selection. And then we can do another one. We can just bring up a battery. Ask me why I have a circuit breaker on my battery. There we go. We can just take a measurement and it's showing 13.26 volts DC. Great stuff. And then we can go to volts AC. It is also a true RMS. If you're not too familiar with what RMS is, your RMS stands for root mean square. And that's going to be handy for any kind of AC voltage or current. And the reason why we have RMS is going to be the value that's output by the meter. And so when we have AC voltage or current, it's a sine wave, right? And it oscillates from positive to negative rapidly back and forth. And so depending at the point in time you take a measurement of that sine wave, all along that sine wave, you're going to have different measurements. So they had to create a way to give you a consistent number no matter what. Your RMS, your root mean square of an AC waveform, is the DC voltage or DC current equivalent of that AC signal. So to have true RMS is something that you're always going to have in a meter if you're doing any kind of AC measurements. Let's just get a load going on here. I do like the backlight in it. And then we can see, okay, 118 volts AC coming out of here. Now this meter is not rated to measure current. It's only for voltages and then the other ones that you see there, which is not a big deal. Honestly, outside of doing this show, I almost exclusively measure current with an amp clamp. If you're not familiar with it, what an amp clamp is, it's one of these guys and you can put this clamp around your conductor and measure the current. We'll go to the resistance setting, manually select it. We've got a few different resistors here that we can use as examples. The nice thing about an auto ranging meter, so that's saying 1 mega ohm, or think of 1 million. Go here. Okay, that's saying 10 kilo ohm. So think of that as 10,000 ohms. So down here, you're gonna wanna see a K or an M, as in Mike, or nothing next to our omega symbol or our little resistance symbol right there. So pay attention, because at first glance, you could think, oh, that's 10 ohms of resistance. Well, it's really 10,000 ohms, okay? And then we can go down here to something very bit smaller. And you can see there's no K or M there. So that is just 99 ohms of resistance. And then kind of like what we demonstrated earlier, we can do hertz, which is great. Let me prop this little meter up for you. We can take something like, you could do like the AC signal that you have coming out of your outlet, should measure 50 or 60 hertz. Or you could do, I'm pretty sure you could do something like this. This little meter outputs a square wave. Astro AI is not an affiliate of the channel yet. Hopefully someday. Okay, it says 47 hertz is being outputted. So if you're not sure what hertz is, so kind of like when we talked about AC signals going from plus to minus, back and forth, it can be really any kind of oscillating signal. Doesn't necessarily have to go into negative voltage or into positive. It can just be on, off, whichever. And then hertz is the amount of times that signal is going to turn on and off per second. So it's saying that whatever's coming out of here is turning on and off 47.7 times per second. So that's pretty cool. It's a nice little function. Capacitance. Whenever we're going to make a measurement of a capacitor, we always want to make sure that we discharge our capacitor. I'm just shorting it out here. You could short it out however. Before we hook it to our meter, because we could damage the meter if the capacitor is charged and we hook our probes up to it. And then you can see this capacitor is polarized, so it has a negative side. So we can put our negative lead to the negative side and then our positive lead to the other. And then we're going to give it a minute to charge up this capacitor, and then it'll give us a value. Okay, and I'm going to press that hold button. That's what that's for, so it can hold the value of whatever you're testing. This capacitor, let's see if I can get this on camera for you, is rated for 680 microfarads. But you can see on this meter, it has a lowercase m indicating millifarads. I misspoke. So it's not a misprint. It is, so they have a decimal here indicating that it's 0.633 millifarads. I wish that since it does have a micro symbol built into this display, it's in there somewhere. I wish it would say 633 microfarads instead of 0.633 millifarads. I misspoke. That's my bad. I think that we're not setting people up for much success doing it that way, but hey, it's a feature available. And then next we can go into diode setting. Now for diodes, we're always gonna test in both directions. And what we should see being displayed, do this hold for us, is we're seeing the voltage drop across the diode. Now voltage drop is a whole nother subject. It's a whole nother video. I'm sure there's a bunch of really great ones out there online. But across the diode, we want to see between 500 and 800 millivolts of voltage drop. So it should say 0.5 to 0.8. And then we'll want to test it in the other direction as well. And we should get that OL should remain, and that's saying that there's no backflow for our diode. So this diode is testing good. And then something I always like to do as a bonus is see if they can light a white LED. And this one does not appear to be able to do so. So that's okay. That's just a little bonus. And then the last two functions are going to be your non-contact voltage. So basically it's like a hot stick built into the meter, and it should be able to pick up live voltage without touching anything. Should be able to just get it close. Let's get this guy live. My bulb's coming loose. And then you can see the H is for high and our signal's in red. And then L is for low. What the threshold of that is and the accuracy, I'm not sure. But I don't like hot sticks. I don't like non-contact voltage, but I do like the live function. Let's see if this is gonna work correctly. Okay, it does. And I wanna show you how this works because this is actually really cool. And this can be very accurate. So the live function, all you need is one probe in your input. And then what you can do is you can set it up, you can go to your box or to your outlet or whatever, and you can use the probe to see which ones are live and not. Here's my neutral, here's my ground, here's my hot. Okay, so that's pretty slick. That is a feature that I actually really do like. I don't prefer the non-contact voltage, but the live voltage is something really great. And then I think we covered just about everything. There is the flashlight function. It's got a great little flashlight on there for you. If you're curious about these CAT ratings, on fluke.com, fluke.com has a lot of great information. They're a great resource for all of us here that enjoy electrical testing. And they have a whole section on category ratings for your meters and your electrical test equipment. I recommend you go read it. Maybe I'll try to put it in the description of the video. Anyways, there is all the test functions of your Jonard Tools AMM-600. Be sure to check out my link tree for any special deals, exclusive offers, discounts, all that stuff. And go ahead and check out another video. If you're still struggling with meter testing and all the different terms and symbols and all that stuff, I've got a ton more videos, and I probably even have the exact meter that you have sitting out in your garage somewhere. I think we're up to almost 30 videos testing different meters from different types and manufacturers and amp clamps and all that good stuff. So there you go. Thank you for joining me in another adventure in the garage. I'm Luke, and I'll catch you on the next one.